So in this example, ladies and gentlemen, something that we've already come across, which what I was expecting you guys to be able to do, was again apply the power to product rule, which I did in the last example. You're going to apply the power. You're going to distribute this power to both of your exponents in the numerator. Okay? But now we have a numerator and denominator. So now I'm going to have to apply it to the numerator and to the denominator, which is called the power to quotient rule. So therefore, it's going to look something like this. Z to the 2/3 raised to the second. X to the 1/4 raised to the second, divided by z to the 1/3 raised to the second, and x to the negative 1/4 raised to the second. Does that make sense, Mariana? What I did? This is exactly what we did last problem. You do the same thing. You just apply that 2. You apply that 2. That power goes to every single one. You got to raise every single exponent to the second power. Exactly what I did here. You raise each and every single base to your m power. Now that I've done that, now I use the power rule, which says whenever I have an exponent raised to a power, I multiply the powers. So now these are all really 2/1s. So how do you multiply exponents? You multiply straight across. Numerator times numerator, denominator times denominator. So therefore, I get z to the 4/3, x to the 2/4, z to the 2/3, and x to the negative 2/4. All right? Now, obviously, ladies and gentlemen, we could go ahead and simplify these. But even without even going ahead and simplify, now I have the z's aligned and I have the x's aligned. So the next thing to do would now be to simplify this by dividing. And remember, when you divide exponents, we do what with the powers? Subtract them. So basically, this is z to the 4/3 minus 2/3, and x to the 2/4 minus a negative 2/4. Make sure you include that minus a negative. Okay? So minus a negative, the reason why that's important, because that becomes positive. So therefore, my final answer is z to the 2/3 times x to the, that would be 6/4, which I can reduce down to 3/2. OK? Now, ladies and gentlemen, we can leave our answer like this. If we were going to rewrite this as a radical expression, then I would rewrite them like that. However, since they do not have the same bases, we cannot combine them at all. All right?
Wait,
yep.
Did the 2/4, did it cancel out or no?
2/4 goes to 6/4, which reduces down to 3/2.
So you added them.
Yeah, because it was minus a negative. Minus a negative turns to a positive. Minus a negative is a positive. So therefore, oh, I'm sorry, that becomes, that should be 4/4, right? I'm sorry, yeah, I don't know where 6 came from either. Sorry, that is, so that becomes 4/4, which is just 1, right? 2/2, which again just turns into 1. So therefore, I could always write this as x times the cube root of z squared if you're going to write it as a radical expression.
Can you give me one